Yeah, lovely to see everybody today, and yeah, my thoughts are also with the flood issues that we're all facing at the moment, and plenty of farmers doing it very tough with that. What I'm going to do today is be a little bit of a fraud. I've got a couple of presentations today, and in both cases, you know, there's significant work by others, and I just want to really point out some work by Jorge Massa and also by David Sheedy. David is our first P2 PhD student, and David's done some tremendous work on this particular project. But what I want to do is put the project in the general context. One of the things that's exciting for us is that people such as Courtney and her mentors, you know, Nigel and Ken Nordland, both of those have done tremendous work over 40, 50 years around facility design. And here in Australia, we've got an opportunity not just to learn about, you know, the sort of systems that they've been very used to, the freestall systems, but what we've got is the opportunity to jump technologies, and we're very interested in the use and application and development of compost barns. And so I'm going to focus a little bit about compost barns and tell a very brief story, because this is very preliminary data, and David's done an amazing job of pulling this data together with Jorge Massa, who's the manager of the farm that we did this work on. And this is the farm. I want to thank in particular Dan O'Brien, Dramana Capital, who owns the farm. I want to also thank Eagle Direct, who supplied the fans, and Integra Engineering, because this is one of the curved type sheds that Integra have put in, and they're a really interesting piece of technology as well. So these guys have actually allowed us to support the research grants around Dairy Up, because it's a New South Wales grant. We're not allowed to go into Victoria or South Australia to use information from there, but because of Eagle, Dan, and also Integra, we're able to actually do some research outside of New South Wales, and that's given us an extra potential thanks to those companies. So I want to acknowledge them. So background. This particular shed's in Timboon, Victoria, which is a reasonably cold, wet area. It lies only a few kilometres from the Great Ocean Road, which is beautiful, and the only trouble with that is that the next stop is Antarctica. So, you know, you can imagine that when the breeze comes up from the south, it's fairly cold and wet, and John Penry just lives a little north of there, but it's much more temperate by the time you get up to Camperdown. We had a very spectacular jump in production when these cows went into the shed. I'd been feeding them for about 10,000 litres or more, and we were only getting about 8,500 on a rolling average. And once these cows went into the shed, they immediately lifted to what they were being fed. So a lot of the impact where we were losing milk was very simple. It was in exercise. The data's there. You can do the stuff out of the NRC. We've actually put cows on treadmill, and it's real. Cows lose milk by walking, and they particularly lose milk when they're walking up hills, and they particularly lose milk when they're having to forage and deal with wet pugged paddocks. So the responses were pretty immediate. Our current production during this trial was about 37 litres, 2.85 of solids, so the cows are milking okay. We anticipate them going up to the sort of figures that Vicky McDonald's achieving with the herds down in South Australia. We'd expect them to be up around the mid-40s in a couple of years' time. The shed operates exceptionally well, except in 2 months of the year. So it is truly a compost barn for about 9 to 10 months of the year, and for 2 months of the year it's quite literally a wet pack. And that's not acceptable to the owner, it's not acceptable to the manager, Jorge Massa, who's a terrific manager, and it's not acceptable to us at Cybus as the advisors of the farm. So what we wanted to do was start a process of trying to understand how do we achieve a perfect environment all year round, and we also wanted to know how cows responded to the fans. So the fans are involved through VES, and they're the 180 centimetre variable speed fan. They've also got variable direction. Unfortunately, during the study we're in a setup phase, and they were variably applied because we sort of were only able to manage a consistent 2 hours a day of fan use because of just teething issues. But in this study what we had was, it's called a cohort study, and what we've got is an effective fan, and you can see how the fans are directed. The feed alleys down here in the centre, you've got these fans laid out, so we had 10 fans, and you know what you've got is space in between. So these areas are control areas, these are the treated areas, and you've got the pen partitions going across here. So that's how it was laid out. So it's basically a cohort exposure study, and our interests were in how the cows behaved and how the compost pack behaved. But there's a lot of data that we haven't analysed, which is particularly around the environment and how that influenced the nature of the pack, both its wetness, whether it was discharging ammonia, whether we were getting any issues around how the cows were behaving with wind speed that was naturally arising. So if we look at the descriptive statistics, the pack temperature was 19.4, and as most people in this room I think will know, is that we needed to be up around the mid-30s for that pack to be truly composting. So we know that the pack wasn't properly composting. Interestingly, it must have been doing something because it's not also at ambient temperature. So there is some action. The volumetric water content was 44.5 grams of water per gram of soil. The ammonia was 0. Now this was one of the things that intrigued us, was there's been a lot of discussion about ammonia in sheds. We did not get any detectable ammonia through this. The wind speed within the shed was highly variable, and we've got to spend a little bit more time trying to work out what the wind speed is, because that's an important metric. Challenge with network problems, limited fan use to about 2 hours a day during this period. If we look at the pack temperature by location, what we see is it's quite interesting. The no fans close to the outside wasn't a lot different, in fact not statistically different at all, close to the outside with fans, despite the typo. And then what we found was that closer to the centre of the shed, the pack temperature was actually a little warmer. Now you'd expect maybe the cows would go towards that warmer temperature, but in fact that's not what we found. So if we have a look at that pack moisture, this is just a histogram, and for some reason we have a very strange distribution with this histogram, and we're not quite sure why, but there is a dichotomised distribution. But what you can see is that the moisture is way above what might be ideal. Ideal is about 40 to 60% on a gravimetric wet basis, and what you can see is that the water content in the pack is too high. Now we're not sure why that arises. Is it a failure of the pack to actually ferment enough and compost enough to drive the moisture out, or is it because we're dragging moisture in from an extremely moist environment? So when you get those southerly wets there, they're a very, very wetting wind. You can feel it in the shed right down near the end, at the northern end, you can feel the moisture coming down the shed. So it's actually a really profoundly quite wetting experience. If we look at the moisture by location, what you can see is there's some evidence that external exposure increased the moisture just slightly. And again, these are not significantly different. You can see just how much overlap there is between the distributions. But what you can also see is it's moister, looking at the median and looking at the distribution as you get close to the outside with no fans. And maybe there's some evidence that perhaps the fans are drying, but certainly not statistical, and it's only a hint. So, that's interesting. There we go. Okay. I don't know what that blank was about. What we can then also have a look at is predicted cow counts, and one of the Sydney University animal science students helped with this work. But what we did was we photographed these cows regularly, so they were photographed once a day at 52 sites, so there was a lot of effort went into photographing and counting the cows. And what you can see is, strangely enough, the cows did not like lying close to the centre of the barn. Now you'd expect with that slightly warmer conditions and away from the moisture, the cows would choose to be there, but that's not the case. You can see there's a very, very marked difference in the concentration of the cows. And what you can also see is that when the sawdust was added, the sawdust started the compost, and what you can see is that there was an association, and a very clear association, of the cows with the sawdust. So you can see that they chose to lie where the sawdust was. And you can also see that close to the outside with fans, there was a tendency for those cows to lie towards where the fans were. So the fans definitely were attracting the cows, so the cows were making that decision. If we look at the predicted cow counts and temperature, this is pretty interesting, because despite that temperature being often higher out towards the inside of the barn, what you found was that in fact they chose again to lie on the outside, but you can see that the cow counts rose quite markedly as the temperature was higher. So cows were seeking that warmer environment within the shed, and that's where they were headed. Future plans. I mean, I'm quite excited. It looks like we've got a really good young PhD student, but I might be biased in that view, hoping that they'll join us very soon on this particular project, because we've needed a PhD. In the southern zone, we've got questions, and Vicky McDonald will probably help us with some of this. What value light in winter? I think it's a really good question. If I look at some of the plasticised barns, you know, there may be value in that extra light in the winter. That could be a valuable addition. The engineers tell me that the light doesn't provide any additional benefit in heating the pack, but I'm doubtful about that. I think it's something that needs to be tested. If we look at the optimal ventilation, the fans we utilised in this study are excellent fans. They're also quite demanding in terms of energy requirement. It was really neat to see Courtney's data around both the cost and the timing that you put that on. How to orient the shed is a key question. In these southern zones where we might want to be using light, how do we best use light? How do we best position versus the wetness of the winds? How can we utilise microbial power to heat? I think there's really important areas that we need to look at in terms of microbial intervention. Can we get microbe mixes that allow us to generate heat at a lower temperature and higher moisture? And the optimal fan design and orientation clearly needs a fair bit of work. You know, it's really interesting to see the sort of figures that Courtney put up with the fan distribution. So we've got really good evidence that the fans are driving those winds where we want, but then how do we combine those with innovations such as the curved, you know, airplane type sheds that Integra produce, and can we enhance those sheds so that we might not need to spend on fans? And lastly, how do we make these cows happy all year round? So that's really our intent. We think that by jumping a technology, we can save a lot of money for farmers around concrete and loops and sand recapture. We think that that's really possible. I've never seen happier cows than in the compost barns for much of the year, but we need to achieve that extra 3 months of benefit across the compost barns to really be achieving our goals. So, thanks, Jan.
Thank you very much, Ian. A lot of good research that will definitely help for farmers when they decide how to go, those that really want to go this path. Any quick question for Ian?
So when you started before the compost barn there, was it like crushed rock and then you put like sawdust on the top, or would you start out with floor tiles?
Yeah, they're fantastic questions, because that's certainly part of what we're contemplating. Some of the things that were really difficult about this particular shed in its inception was that we had an existing feed pad, so we retrofitted the shed over the feed pad. The feed pad had some fractures in the concrete, and they were devastating, because what they did was they bled water into the shed. And the bottom line is that I think if you're going to put them onto clay, you need to think very, very significantly about the sort of drainage that you establish around that base. And I'm now very much of an opinion that you probably need agricultural draining in the base. You need to have a sand packed, and that sand pack then goes above your initiation of the compost. And I guess part of your question inherently I hear is, what did you start it with? We started that one with wood shavings. My preference is very much for starting it with compost. So if you can, you know, pile up a whole lot of manure and compost it, that I think is a better bedding start than just a straight sort of wood shaving type start.
And how often does it actually go around, like the
Yeah, twice a day that shed's cleaned. So the cows are milked 3x, and the till goes round twice a day. And I think that's one of the other questions we've got. You know, I'm not sure that in tilling it in cold weather, you're not actually introducing cold moisture and actually destroying the fermentation or the composting because of introducing the moisture. So you want to get the air in there because it's an aerobic composting process. But, you know, if you're actually turning over moisture and burying it and it's cold, you may be destroying the composting action you've got. So there's stuff there we've got to learn.
We have another question here, yes.
Hi, Ian Errol Gerber from Lowood. Ian, the work you've done there so far, or what you put up there today, was in the southern parts of Australia. To us in the subtropical area, we're looking at a totally different thing. It's more we're looking hot, humid weather. Our compost barns, how do we deal that with our hot, humid weather? And if we haven't got fans, how do we deal with the groupings of cows? You know, because we all would like fans, but we don't actually have the finances to do all these things up front.
Yeah, look, those are the sort of terrific questions. It's great to see you. I think they're the sorts of questions we're posing to ourselves as a group, and we're going to try and knock over as many of the questions as we possibly can during the process of dairy up and hopefully extensions of dairy up. But you know, each of those environments we've put sheds into have been really different, and each of them has required significant learnings, even in the preparation. So I would say that the investment in fans into your region is pivotal. And you know, you've only got to look at the data, and I think Cameron Clark's group are going to present some terrific information on the effects of environment on performance. We're certainly looking at the effects of the environment between the intensive and extensive farms, and how the extensive farms might respond under heat stress differently to the intensive farms where you've got some stuff going on. We're very keen, you know, to have that sort of information from northern New South Wales, southern Queensland into that data set if we can, to try and look at, you know, how do you optimally set these things up for each of those different environments. But I would say very strongly that both wetting cows and then cooling cows with fans is absolutely critical to the northern environment, because it is heat stress, not winter stress, that is the problem. So, you know, we're seeing sheds go in places like Tasmania. We've got one under the bubble at the moment about the head there, and that's about the winter stress. Whereas up in your region, we've got to deal with the summer stress, because it's not unusual in northern New South Wales, southern Queensland to see 8-10 litre drops over the summer, and the cows only just recover by, you know, late spring to get slammed again next summer. So you've got to break that cycle.
Thank you very much, Ian. And with that, please put your hand together for Ian Lin, and thank you for the presentation.